In this lesson, we're going to be simplifying radical expressions. A radical expression has a couple of different components. First, you have the radical symbol itself and the contents of the radical symbol, which is called the radicand. When simplifying radicals, it's really helpful if you can know and recognize the perfect squares. For example, 2 times 2 equals 4. So 4 is a perfect square, a product of two matching factors. So we're going to list the perfect squares, and we're going to start with the smallest perfect square, 1 times 1, which is 1. And then the next perfect square is 2 times 2, which is 4. The next perfect square is 3 times 3, which is 9, and so on. The perfect squares continue infinitely, but we'll just write out a few. Now, a square root is whatever matching factor was used to create that perfect square. So for example, here we did 1 times 1, so the square root of 1 is 1. Here we did 2 times 2 to get 4, so the square root of 4 is 2. Here was 3 times 3, and so the square root of 9 is 3. Whatever was the matching factor that was multiplied times itself, or squared, in order to get the perfect square number. To write a radical expression in simplest radical form, there are 3 important things that we need to do. First, we need to make sure that there are no perfect square factors in the radicand. Of course, that doesn't include 1 because 1 is a factor of any number. We need to make sure that there are no fractions under the radical, and we need to make sure that there are no radicals in the denominator of a fraction. What we're going to do to simplify these expressions is we're going to find the biggest perfect square factor of the radicand, and we're going to evaluate its square root, bringing it out, and then we're going to leave the non-perfect square factor inside. For example 1a, we're taking the square root of 16. 16 is a perfect square, and the root is 4. A common mistake students make here is that they think, oh, 4 is a perfect square, and I'll take the root of that again. But once you use that radical symbol, it's simplified, and you won't take the square root again. Next, we have the square root of 8. We want to divide 8 by a perfect square on the list up above, and the only number that's smaller than 8 on that list is 4. So we're going to split 8 into 4 times 2. That'll be radical 4 times radical 2. And then we'll take the square root of the perfect square factor, which is 4, and put it on the outside. The square root of 4 is 2. Then the non-perfect square factor will stay inside the radical. So that'll just become 2 radical 2. The next one, square root of 75. So if I look up here at my list, 75 would fall between 64 and 81. So I'm going to divide 75 by numbers that are less than 81 on this list. So I might divide 75. I know 64 can't go in evenly. I know 49 can't. And I'm just going to move down this list. 36 can't go into 75, but 25 can. So I'm going to split 75 into 25 times 3. Square root of 25 times the square root of 3. Notice that I still have my radical symbols. I haven't taken the square root of either of these numbers yet. I've just split 75 into 2 factors that when I multiply them back together gives me 75. The perfect square number is 25. I'm going to take the root of that number and bring it out. So the square root of 25 is 5. And then the non-perfect square factor, 3, will stay inside the radical, giving me 5 radical 3. Next, we'll work on D, square root of 40. So 40 falls between 36 and 49. So I'll start here and work my way down. 40 cannot divide by 36, cannot divide by 25, cannot divide by 16, cannot divide by 9, but it can divide by 4. So I'm going to split 40 into square root of 4 times the square root of 10. Notice that each time I am dividing by perfect square factors. My goal is to find the biggest perfect square. So I'm not just dividing 40 by any numbers that work. I'm not splitting 40 into 20 times 2 because neither of these is a perfect square factor. And I'm not splitting 40 into 5 times 8 because neither of those is a perfect square factor. My goal is to find a perfect square factor that goes evenly into 40 so I can take the square root of it and bring it outside. So the square root of 4 is 2, and there are no perfect square factors inside of 10. Again, if I look back up here at the numbers that are smaller than 10, none of those numbers would go in evenly, so I know it's simplified. And so 2 radical 10 is the simplified form. Next, square root of 45, so I'm going to start between 36 and 49 again, and I'm going to work my way down. I can see that 45 can divide by 9, and that's the biggest perfect square that goes in evenly. So that's going to be 9 times 5. I take the square root of 9, which is the perfect square factor, and bring out the 3. And then I take the non-perfect square factor and leave it inside a radical symbol. And finally, we have square root of 600. It's pretty clear that 600 could be divided by 100. 600 is 100 times 6, and so my perfect square factor is 100, and the square root of that is 10, and my non-perfect square factor is 6, and so that will stay inside the radical. So each of the perfect squares that we listed up above represents a pair of matching factors. For example, if we're working on square root of 9, square root of 9 is the same as square root of 3 times 3, and so the root of it is 3. Or square root of 25, that's a pair of 5s, and so the root of it is 5. A perfect square is literally a repeated multiplication of 2 matching factors. So we're going to use this concept to simplify radicals that also contain variables in the expression. So example 2a, we have the square root of 4x squared. Just to emphasize this concept a little bit, I'm going to expand this. I'm going to rewrite 4 as 2 times 2, and I'm going to rewrite x squared as x times x. We have a pair of matching factors in 2 times 2, and a perfect square is a pair of matching factors. And so the root of that will be 2. So we'll bring out a 2, and then we have a pair of matching factors in x squared, x times x, and so we can bring out the root of that pair, which is x. So both of these roots will come out of the radical, and the result will just be 2x. Now the next one is a little bit trickier because we have to simplify. A good trick is to round your number to maybe 100. 98 is close to 100, and start at about half of that. So up here in my list, I'll go to about half of 100, which is 50. So that puts me at 49. So I'll start by dividing by 49, and if 49 doesn't go in, then I'll just move down the list until I find the biggest one that goes in. But conveniently for this one, 49 does go in. And so I'm going to split 98 into 49 times 2. Now let's take a look at the variables. The a's, I have a times a times a times a. This is 2 perfect square pairs. And then for the b's, we've got 10. There are 1, 2, 3, 4, 5 pairs. Here's how this will simplify. The perfect square, this is 7 times 7. So a 7 will go outside the radical for that. And then you've got your 2 a's and your 5 pairs of b's. And then the only thing that's left inside the radical that's not a perfect square is the 2. And then we'll simplify by writing that as 7a squared b to the 5th radical 2. For example, C will divide 27, so I would probably round 27 to 30. And my perfect squares are 1, 4, 9, 16, 25, etc. Round 27 to 30, half of that is 15. 16 is close to 15. It doesn't go evenly into 27. So then I'd move on to 9. 9 goes evenly into 27. So I'm going to split 27 into radical 9 times radical 3. 9 times 3 is 27. And then I'm going to expand out my z's. I have 3 z's. So I have a pair of 3's here in the 9, so that'll come out. This 3 is not a perfect square. I can't split it into 2 matching factors like I could here. This I could split into 3 times 3, that's 2 matching factors. And then here I've got a pair of z's, so that will go outside. And then these 3 and z will stay on the inside of the radical. So again, the perfect squares are going on the outside and the non-perfect square factors are remaining on the inside of the radical. For example 2D, we're going to do a similar process. Now, hopefully you've noticed that a shortcut that we can take is dividing the exponent of the variables by 2, and that'll give us the number of pairs. And then if it's odd, you'll have 1 left over inside of your radical. So 48 is close to 50, half of that is 25, so I'm going to work my way up my list, 1, 4, 9, 16, 25, start with 25, it doesn't go evenly into 48, but 16 does. So this is an example of if you started with 4, 4 does go into 48, but there would still be more perfect square factors inside. So that's why we want to start with the bigger numbers and work your way down towards the small numbers. So 48, I'm going to split into 16 times 3. I've got an x, a y to the 5th, and z to the 9th. So 16 is a perfect square. It's 4. And what I like to do normally when I'm just working them myself is I just leave some space to put my variables, and then I go ahead and put the leftovers on the inside and I just work my way across the problem. So this x cannot be made into a pair, so it will have to stay on the inside. Y to the 5th, I could get 2 pairs out of that, so y squared will go on the outside with 1 remaining. A quick way to think about this as kind of a mental math thing, your exponent is 5. You're going to divide by 2 because you're wanting to group them into pairs. 2 goes into 5 2 times. 2 times 2 is 4. Your remainder is 1. So 2 will be on the outside and 1 will be on the inside. So that's just a little quick long division way of imagining it. So we have our 2 on the outside and 1 on the inside. We'll do the same thing with the z's. So we're dividing by 2, either in your head or on your paper. 2 goes into 9 4 times. 2 times 4 is 8, and the remainder is 1. So there'll be 4 on the outside and 1 on the inside. So z to the 4th on the outside and z to the 1st on the inside. For E, 100 is a perfect square and the root is 10, so 10 will go on the outside, and I'll go ahead and put my radical. 12 divided by 2 is 6, so that'll be 6 on the outside with no remainder. And then y to the 7th, 7 divided by 2 is 3, 2 times 3 is 6 with a remainder of 1. So there'll be 3 on the outside, 3 pairs, and then 1 left over on the inside. So y to the 3rd on the outside and y to the 1st, or just plain y, on the inside. All right, for this last one, we're doing 180. Half of 180 is 90. So the closest perfect square to 90 is 81. So we'll divide 180 by 81, and that one doesn't go in evenly. So then we'll do 180 divided by 64, and that also doesn't go in evenly. Then do 180 divided by 49, and that does not go in evenly. 180 divided by 36 is 5. So you'll do 36 times 5 is 180, and then that's square root of 36 is 6. Leave some space and put your 5 on the inside. And then a to the 3rd, you're going to get a pair of a's with 1 left over. And then b to the 6th, 6 divided by 2 is 3. So you get 3 pairs of b's there. Now you're ready to practice in your packet simplifying radicals and radical expressions with variables. Good luck.